very great privilege to introduce the Revd Dr Polkinghorne again to you. He was Professor of Mathematical Physics here in Cambridge. He gave up that chair to study theology and to train for ordination in the Church of England. He was a parish priest for a few years, and of course lured back into academia as Dean of Trinity Hall, I think it was first, and then President of Queen's College. He has written very extensively in the area of science and religion, and a lot of his books are on the bookstall. I hope you've had a chance to browse and maybe buy some books. John was the recipient of the Templeton Prize in the year 2002. He's also been very active in the higher councils of the Church of England and on government advisory bodies to do with ethics and so on. So there's no better person qualified, I think, to speak to us this afternoon. Thank you. And on a subject dear to my heart, the Anthropic Principle.
Well, thank you, Rodney. Yeah, I'm going to try and talk about the Anthropic Principle. One of the best books about the Anthropic Principle is one written by Rodney, which I saw some copies of on the back. It has the rather comprehensive title of God, the Multiverse, and Everything. So you should be able to find something in the book that would be of interest to you. Well, we know, of course, that the universe, as we observe it today, started at 13.7, they're getting very exact cosmological measurements, 13.7 billion years ago, in the fiery singularity of the Big Bang. And it all started, of course, extremely simple. I mean, the very, very early universe is an almost uniform expanding ball of energy, just about the simplest physical system that you could think about. And that's one of the reasons, I think, why cosmologists can talk with often a justified boldness about things that were going on pretty early in the history of the universe. Well, the world that started so simple has now, of course, become very rich and complex and differentiated, with you and me, in fact, the most complicated consequences of that 13.7 billion year history, at least of which we are aware. I mean, the human brain is far and away the most complicated physical system in its interconnectivity and so on that we've ever encountered in our exploration of the world. So even thinking about that might suggest that something has been going on in cosmic history. That what started so simple has now become so rich and complex. Also, of course, we know that the way that's come about through our unfolding history has been through a whole sequence of evolutionary processes. Not just the evolution of life here on Earth, that very familiar story that you've been thinking about, but also the physical universe has evolved in that sort of way. Evolutionary process involves some subtle interplay between those two slogan terms representing two propensities in the world of chance and necessity. Chances are the most slippery words. Chance is a particularly slippery word. It doesn't mean the capricious acts of the goddess Fortuna. It simply means historical contingency. That this happens rather than that. The range of possibility of what might happen in the world is so great that only a tiny fraction of conceivable events have actually happened. Necessity, of course, stands for the lawful regularity of the world. And for example, one of the first important developments in cosmic history, which took place when the universe was about 1 billion years old, and actually one of the less well understood aspects of cosmic history, was the condensation of galaxies and of stars within the galaxies, an extremely important and indeed essential development in a fruitful universe. That evolving process was seeded by chance. In the very early universe, I said it was almost uniform. It wasn't quite uniform. There were slight fluctuations in that expanding ball of energy. Almost certainly, principally deriving from quantum fluctuations. In that pre-Planck era, when the universe was less than 10 to the minus 43 seconds old, when quantum effects were operating cosmos-wide. It's just by chance there was a little bit more matter energy here than there. If that's the case, that's contingency, that's chance. But if that's the case, then of course there'd be a little bit stronger gravitational attraction, drawing more matter into here rather than there. And that begins a sort of snowballing effect, which over about 1 billion years or so produces the primeval structure of stars and galaxies in the universe. So that's an evolutionary process quite as much as the development of life. Now, what we've come to realize as we've understood more about this whole sequence of cosmic processes that have been going on is that the necessity half of the chance and necessity interaction also has very remarkable properties, and in fact has to take a very specific, very finely tuned form if in fact that evolutionary exploration of possibility, that shuffling exploration of potentiality, which is really what chance means, if that is to produce eventually such remarkable consequences as you and me. It's not any old world that could produce carbon-based life. That's really what the Anthropic Principle is about. It's saying that the laws and circumstances of the universe have to take a very specific form. The physical fabric of the world, the character and the strength of the fundamental forces that are acting in the world have to lie within very, very narrow limits, and other circumstances also perhaps have to be adjusted if a universe of our kind, with the kind of fruitfulness that is exhibited, is to be possible. That came as a very big surprise, I think, to pretty well all scientists. Certainly came a big surprise to me, I must say. Our general inclination was to suppose that our universe was just a fairly common or garden specimen of what our universe might be like, nothing very special about it. And it not only came as a surprise to a good many scientists, but also came as a bit of an unwelcome shock, because as I was saying yesterday in a rather different context, the instinct of a scientist is to think in terms of the general rather than in terms of the unique. And what the Anthropic Principle is saying is not that our universe is literally unique, but it is very, very special indeed. And that seemed to be a disagreeable idea to quite a lot of people. And part of the disagreeableness, which we'll come on to think about in a bit more detail in a minute, lay in the fact that that might suggest that maybe there was some sort of theistic purpose lying behind that very special character of the universe. Incidentally, it's called the Anthropic Principle, but what it's really about is the specificity of a world that can produce carbon-based life. I mean, it's not being suggested that five-fingered Homo sapiens was built into the potential structure of the world from the start. Of course there is a role for chance, of course there is contingency, but the fact that carbon-based life, and presumably then in appropriate circumstances the development of conscious and self-conscious life, does seem to have been part of the potentiality of the world from the start. It might have taken 10 billion years before any form of life emerged, almost 13.7 billion years before any form of conscious life appeared, but the potentiality of that was there from the start. Well, let me, you probably know all about this, but let me at least give you some illustrations of why we think that's so. If you're going to have a fruitful universe, one of the most important things that you have to get right in it is you must have stars, and you must have the right sort of stars. And the stars have really two fundamental roles to play. One is simply to fuel the possible development of life on an encircling planet. You've got to have a supply of energy to get life going and to keep it going. And life has been able to develop here on Earth over a period of about 4 billion years or so, because our local star, the Sun, has been shining more or less steadily, I mean some fluctuations, but more or less steadily over that sort of period. And we know, and you need about 4 billion years to develop, excuse me, to develop complex life. There's a whole natural timescale for it. It's not something you can do overnight. Now we understand the way stars behave pretty well, and when you figure out what makes long-lived, steadily burning stars, you find that it depends very critically upon a balance between two of the fundamental forces of nature. One is gravity, and the other, it turns out, is electromagnetism, a much stronger force which holds matter together. The seats on which you're sitting are held together by electromagnetism, and in fact you are held together by electromagnetism. It comes to that point. And if you alter that balance, then the way stars behave changes very, very quickly and very radically. If you alter the balance in one direction, then stars will begin to burn much, much more intensely than they do in our universe. They will simply pour out energy, and that means that they will very soon burn themselves out. You will soon be in a situation where stars aren't living for billions of years, which you need to fuel the billions of years development of life, but only for millions of years, and that's just too short a time to be of any use. On the other hand, of course, if you shove it in the other direction, then stars will burn very, very dimly. It will be brown stars, and you won't really have enough energy being available to support life. So you need a delicate balance between electromagnetism and gravity to get the right sort of star, the kind that we have in our world. But the stars have a second role to play, which in some sense is even more critical, and that is simply to provide the chemical raw materials of life. The very early universe, because the very early universe is very simple, for about the first 3 minutes of its life, it's a sort of cosmic hydrogen bomb with nuclear processes taking place universe-wide, but very soon its expansion has cooled it down, and those thermonuclear reactions cease. And because the universe is simple and they don't go on for very long, it only succeeds in making the two simplest chemical elements, which are hydrogen and helium. And our universe, on the grossest scale, is 3/4 hydrogen and 1/4 helium. And you can't really do very much with those two elements. They have a very boring chemistry. So you need lots more elements. In fact, for life, you need about 20-odd elements, but one of the key elements you need, of course, is carbon. The chemistry of life is the chemistry of carbon. Biochemistry is essentially carbon chemistry, because carbon has the ability to make these long-chain molecules that seem to be the chemical basis of life. But the early universe doesn't make any carbon at all. So where does carbon come from? Well, there's only one place in the whole universe where carbon can be made, and that is in the interior nuclear furnaces of the stars. Every atom of carbon inside our body was once inside a star. We're not just made of the dust of the earth, we're made of stardust. We are made of the ashes of dead stars. And one of the very big triumphs of second half of the 20th century in astrophysics was figuring out the sequence of processes by which carbon and heavier elements beyond carbon, like oxygen and so on, were created in the stars. And a lot of that work was done here in Cambridge, and the leading figure here in Cambridge was Fred Hoyle, who was a senior colleague of mine in the Applied Maths and Theoretical Physics department here in Cambridge. And the people who were working on that process were really sort of flummoxed from the start of it, really. Because the first element they seriously wanted to make was carbon. They had helium, helium-4. If you can get 3 helium nuclei to stick together, that will make carbon-12. But of course, when you're dealing with things as small as nuclei, it's essentially impossible to make 3 to stick together at the same time. So obviously what you've got to try and do is to do it sequentially. You stick 2 together, that makes beryllium-8, and then you hope that might stay around for a bit, and from time to time a third helium nucleus will come along and stick on and turn beryllium-8 to carbon-12. That's the obvious thing to think about, but it doesn't work in an obvious and straightforward way. And the reason it doesn't work is that it happens that beryllium-8 is extremely unstable, and it just doesn't stay around long enough to capture that third helium nucleus in any, let's say, simple, straightforward method. So they seem to be stuck. On the other hand, all these chaps were thinking about it, they're carbon-based lives, so they knew that there must be some way of doing the trick. And Fred one day had a very bright idea, an idea for which he also won a Nobel Prize, by the way, that's another story. And he saw that it would be just possible for the beryllium, even in its short lifetime, to catch that extra helium nucleus if there was a resonant effect, an enormously large enhancement effect, present in carbon-12, the end product of the process. That would make the process go very, very fast enough to catch that elusive beryllium. But it would only go fast if the resonance was not only there, but also there at the right energy to enable that to happen. So, by thinking about how elements might be made inside stars, Fred concluded there must be resonance in carbon-12 at a particular energy. And so, from that, feeling pleased with himself, he went off to the nuclear data tables, looked them up just to check that that resonance was there. And it wasn't. But he knew it must be there. He couldn't think of any other way carbon made. So he rang up some friends of his in the States, a father and son team of very clever experimental nuclear physicists called the Lawrence's of Caltech. And he said, look, you chaps have missed something. There's a resonance level in carbon that you haven't found. And I can tell you exactly where to look for it because he knew what the energy had to be. So you go and look. Apparently, the Lawrences weren't too keen to go and do that. They, I don't know why, but it was probably a delicate, difficult experiment. But Fred's not the sort of person who put up with people saying no to him for very long. So in the end, they were persuaded to have a look, and of course they found it. And that's the most wonderful scientific story. It's the Nobel Prize character to think about the formation of elements inside stars and to deduce from that a detailed property of the nuclear energy levels in carbon is a most astonishing piece of scientific reasoning. Every time I tell this story, and I've told it a good many times now, every time I tell that story, I'm enthralled by it, really. I think it's a wonderful effect. But it had a further consequence for Fred, beyond obviously the scientific satisfaction of a very bright idea, and it was this. Fred realized, of course, that if the laws of nuclear physics, the forces that control what the energy levels in carbon would be, if those forces had been, even to a small extent, different, either there would have been no resonance at all, or it would be somewhere else, or some different energy, which made it useless. And he was bowled over by that. And somehow or other, the fundamental physical fabric, as far as nuclear physics is concerned, in the world was such as to permit, in an essentially unique way, the generation of carbon. And he is reported to have said, in a Yorkshire accent that I'm afraid it's beyond my powers to imitate, the universe is a put-up job. This can't be just a happy accident. It's far, far too significant a coincidence for that to be feasible. And Fred had a lifelong commitment to atheism, and of course he didn't like to use the word God, so he said there must be some capital I intelligence fixing up the laws of nature, which seems to be a rather feeble attempt to finesse the threat of theism. So that's one example of the sort of fine-tuning that needs to be present in the given physical fabric of the world. We're talking about the things that science itself has to treat as its given starting point. Science doesn't explain the laws of nature, it discovers the laws of nature and then uses them to explain the processes of the world. We're saying that those laws themselves have a character that seems, so to speak, not self-explanatory, that seems to point beyond themselves, to require some further explanation. Now you have to be careful when thinking about these things because maybe what looks like a finely tuned coincidence might arise from some deeper cause which you are not altogether aware. And there's another very sharp, in fact perhaps almost not quite the most exacting anthropic coincidence, which might seem to have that character. Another necessary character of a universe that's going to be fruitful is that in its early stages there should be a very close balance between the expansive effect of the Big Bang driving matter apart and the cohesive effect of gravity seeking to pull things together. They must be very closely aligned with each other. If you have too much gravity, the world will simply collapse again before it has the time really to get going. If you have too much expansion, everything will fly apart so fast that it will become so dilute that no interesting processes can take place. So you need a very close relationship between expansion and contraction in that way. In fact, if you extrapolate things back to the Planck time, 10 to the minus 43 seconds, which is it is certainly as early as you could even pretend scientifically to be able to talk about, you conclude that the balance between the two at that era, just by a straightforward, naive extrapolation, should be 1 in 10 to the 60, which is pretty close. In fact, Paul Davis, writing about these things, compares that degree of precision to taking a target a couple of inches wide, putting it on the other side of the observable universe, and hitting it with your bow and arrow, which is a pretty good shot, actually. But actually, maybe you don't have to have it quite as finely tuned as that, because later on, Alan Guth comes along and produces a speculative but very persuasive theory of what might be happening in the fairly early universe, but say when the universe is about 10 to the minus 35 seconds old, still quite young really. He believes that then there will be a process taking place which he called inflation, which was a sort of boiling of space. In the trade we'd call it a phase transition, which blew the universe apart very, very rapidly for a short while, and then ceased. And it's the ceasing actually which is hard to get right about all this, but that's the general picture. And if you have such a process, it tends to smooth things out. Like the graphical expansion tends to smooth things out, and you can see by following it through that that process could produce this subsequent very fine balance between expansion and contraction, even if it hadn't been present in the universe before 10 to the minus 35 seconds. So that's an example, a warning example, I think, of an apparent coincidence, which nevertheless could be a physically engineered coincidence if a certain type of physical process was taking place and possible in the very early universe. But even that, of course, doesn't remove anthropic particularity, because it's not every form of the laws of nature that will produce an inflationary scenario, and particularly won't produce an inflationary scenario that does its work and then stops. I mean, it's not too hard to get into inflation, but it's quite hard to get out of it in any acceptable way. So there would still be something very specific about the laws of nature which would permit the inflationary scenario. So that's the second example, or second modified, qualified example of anthropic fine-tuning. Let me have a word not just about laws, but about circumstances. We live in a universe which is immensely big, as I'm sure you know. There are about 10 to the 11 stars in our local galaxy, the Milky Way. And there are about 10 to 11 galaxies in the observable universe. So there are about 10 to the 22 stars in the observable universe, an immensely large world, very hard to think about, in fact, to take in. And sometimes people feel, sort of upset at the thought of the vastness of the universe. Think, here are we, the inhabitants of no more than a speck of cosmic dust, really. What possible significance could there be set in this vast world, almost unimaginably vast world? Well, it would be pretty silly, I think, to identify size and significance. I think that there are some things that are special about us, like self-consciousness, which doesn't seem to be widespread in the universe. But quite apart from that, if all those stars weren't there, we wouldn't be here. We'd be upset at the thought of them. Because there's a very close connection between how big the universe is and how long it lasts. And a universe that's going to last the order of 14 billion years has to be at least as big as our world with 10 to 22 stars in it. So if they weren't there, we wouldn't be here. So again, it shows you have to be sort of careful about it. couple more illustrations. I'm ramming this home, but let's take the most exacting of all the anthropic coincidences is something that used to be called the cosmological constant, is now called dark energy, which is a sort of anti-gravity effect, which is present in the universe, and which is driving and accelerating, we believe, the expansion of the universe. Obviously, that has to be very small, because if it was any reasonable size, it would have driven the world apart and made it too dilute. It is, in fact, very small. You can make an estimate. It's connected. It's essentially an energy associated with space itself. And you can make an estimate of what magnitude of energy you might expect to be associated with a lump of space. And when you compare that with what appears to be the observed value of dark energy is smaller than the normal expectation by a factor of 10 to the minus 120. That's a really big degree of exactitude. It's, I think, the most exacting condition. So there we are. We live in a very remarkable world, and I think that there's really not any disagreement really among competent scientists about the fact that that's the case. Then one more point I want to make, and it's not, I've been talking about magnitudes of things, the strength of the forces, the size of the universe, but also just the general character of physical process is undoubtedly also important for the anthropic fruitfulness of our universe. It's harder to establish this in a rigorous way, but intuitively it seems fairly obvious. One of the insights of science is that regimes of novelty, of creativity, when new things emerge, are always regimes that are operating on the edge of chaos. They're always regimes in which order and disorder interlace each other. If you're too much on the orderly side of that border, then things are too rigid for anything really new to happen. You can have rearrangements, the bits of Lego that nature has at its disposal can be shifted around, but you don't get any new bits of Lego to play with in that sort of way. The world is too rigid for that to happen. If you're too far, on the other hand, on the chaotic side of that border, then things are too haphazard for any new thing that emerges to be able to persist. You need a delicate balance between order and disorder at the edge of chaos if you're going to have fruitful processes. I mean, a very simple illustration, of course, is genetic mutations. If you didn't have any genetic mutations, you'd have no new forms of life. If you had genetic mutations all the time, in very large ways, you'd have no quasi-stable species established on which natural selection can act. So you need to do that. A rigidly Newtonian world, a Plassian world, would have been too rigid, I think, for really fruitful process to be possible. The quantum theory, with its mixture of order and disorder, of lawfulness, but also of probabilistic lawfulness, seems to me the sort of fundamental character of the laws of nature which is almost certainly necessary for a world to be created. So that may be another form of condition. Anyway, I think I've laboured, but I hope I've made the point that we certainly live in a universe that is very remarkable in its specificity, and that's connected with the equally remarkable fact that it has been evolved into the home of carbon-based life. And I think all scientists would agree, essentially, in what I've said. Where the argument begins, of course, is what do we make of that? In other words, when we move from physics, if you like, to metaphysics, to interpret that. And basically, there are three strategies that have been proposed and followed. One of them simply says, well, look, come on now. If it wasn't like that, we wouldn't be here. So it's just a brute fact about the world, it's a happy accident and all that sort of thing. But there's really not much to talk about because we wouldn't be able to talk if things hadn't been that way. Now that seems to me to be too intellectually lazy a position to take. It's too happy an accident not to call for some explanation. When you find something which seems very remarkably precise, but also seems to have very remarkably fruitful consequences, I think you are right to ask whether there might be a more profound understanding which might make that intelligible to you, so it doesn't become just a freak. Now, I think that one needs to move on from that. Now, one of the persons who's been, I think, very helpful in helping one to think about the Anthropic Principle is a philosopher. That's a pretty generous mission for scientists. Philosopher John Leslie, who is an Englishman working in Canada, and he's written one of the best books about the Anthropic Principle. He gets the science of it right, at least right in his day. There have been minor modifications since then. He wrote a book called Universes, which was published, I think, in 1989. And what's interesting about Leslie is that he does his philosophy by telling stories, basically, which is a very nice way of doing philosophy, at least for a person like me who's not professionally trained in the subject. He's a parabolic philosopher, in other words. And here's one of the stories that he tells. You are about to be executed. You are tied to the stakes, your eyes are bandaged, the rifles of 50, he says, highly trained marksmen are levelled at your chest. The officer gives the order to fire, the shots ring out, and you find you have survived. So what do? Do you shrug your shoulders as you walk away, saying, gee, that was a close one? Of course, if you hadn't survived, you wouldn't be able to make the remark. Just as if the universe hadn't been finely tuned for life, we wouldn't be here talking about it. But nevertheless, your escape from that execution seems so remarkable a fact that it seems you must seek some rational explanation of your amazing good fortune. And Leslie says, really, there are only two rational classes of explanation. One might be that in fact there are many, many, many executions taking place today. Even the best of marksmen occasionally miss. And you happen to be in the execution in which they all miss. If there are enough executions taking place today, and obviously there's going to have to be a colossal number to make this argument at all persuasive, that's a rational explanation of what's going on. So that's one possibility. But of course there is a second possibility, which is maybe there's only one execution scheduled for today, named yours, but more was going on in that event than you were aware of. Maybe, in fact, the marksmen were on your side, and they missed by design. But you see how those two are charming, how that charming parable translates into thinking about the fine-tuned universe. First of all, we should look for an explanation of it. We shouldn't just take it as a brute fact. And Leslie says, basically, there are only two rational kinds of explanation. One is maybe there are just lots and lots and lots, and again, there has to be a vast, vast number for this to work, lots and lots and lots of different universes, with all sorts of different laws of nature. Strong gravity, weak gravity, this, that, and the other, quantum mechanics, something else, and so on and so on. If there are enough of these in this vast, vast multiverse, then maybe, I mean, you can criticize this, and Roger does criticize it, but at least you might think it's at least a going thing to argue about, that if there are enough of them, then just by chance, in one of them, things will be okay for carbon-based life. And that's the one in which you and I live, of course, because we are carbon-based life. In other words, this pictures our universe as just being the winning ticket, so to speak, in a multi-cosmic lottery to produce, which the prize is producing carbon-based life. Well, that's a possibility. The first thing to recognize about that thing is that it's a metaphysical possibility. It's not a scientific possibility. People try and dress up in highly speculative forms of science the idea of generating lots and lots of universes, lots and lots of different laws of nature. But those theories, at the very least, require a degree of variation in the kinds of laws of nature that are thus generated that doesn't seem to me to have the slightest scientific support. We only have actually, of course, observational knowledge of the one universe in which we live. It's a metaphysical speculation that there is a multiverse, it seems to me, and it's a pretty ontologically prodigal form of explanation. We really do a lot of these things. But of course there's another possibility, which corresponds to the marksman we're on your side thing. Maybe there is just only one universe, but which is the way it is, in its finely tuned fruitfulness, because it is not any old world. It is in fact a creation which has been, whose laws of nature have been ordained by its creator in order to give it a fruitful history. So multiverse or creation. Each of them, of course, is a metaphysical point of view. It goes beyond certainly what science itself is able to explain. And each of them, I think, as it's correct to say, each of them potentially, in fact, actually does the explanatory work that you're looking for. So which should we choose? Well, Leslie says he doesn't know which to choose. He thinks it's 50-50. 50% chance of one, 50% chance of the other. And I think that's probably right. in relation to the question of anthropic fine-tuning. But there are other arguments in favour of regarding the universe as being a divine creation, which also need to be put into the scale. There is the beautiful order of the world, and so on, sort of natural theology. I don't know whether Alistair talked about that yesterday or not, but many people see the deep and rationally beautiful order of the world as being a sign of the mind of the creator behind it. There is, of course, the testimony of religious experience, the very widespread testimony of religious experience with the encounter of the sacred. So there is a sort of cumulative case for theism which mounts up and in which anthropic fine-tuning can find a place, but is not the sole pillar supporting that argument. But it seems to me when you come to the multiverse, there isn't any. It's simply there to do the work of explaining or explaining away the actual fine-tuning of our particular universe. So while I think Leslie is right in saying it's 50-50, once you start thinking beyond the anthropic principle, the anthropic problem, if you like, there are justifiable grounds for preferring the theistic solution of the problem. And if that's the case, the anthropic principle has a natural connection with religion. It naturally offers some support, not a knockdown argument, of course, but I don't think that one has access to that kind of argument, either for or against the existence of God, or the existence of spiritual reality, or whatever one likes to talk about. But at least it has a connection with it. Now, before we have a talk about this, have a conversation about this, there are a couple more points I'd like to make about it. First of all, some people suggest that, in fact, this notion of tuning, of the variety of possible strengths of the forces of nature and things like that, maybe that's an illusion. People say maybe there is only one truly consistent theory of nature, and if we really knew that, it would determine everything. There would be no arbitrary parameters in the theory. And people are a little bit pushed in that direction because of the notorious difficulty which has bedeviled 20th century physics in being able to combine in a consistent way its two most fundamental discoveries, quantum theory on the one hand and general relativity, the modern theory of gravity, on the other. Putting those two together is a still not completely resolved problem, even more than 80 years after the discovery of quantum theory. And there are, of course, possibilities of differingly estimated degrees of attractiveness, such as string theory, but we don't entirely know how to do that. And some people suspect that if we really knew how to put those two together, then we'd find that there was only one way to do it. That way was so exacting that there were no arbitrary parameters left in the theory. If you think that string theory is a guide to what that theory might look like, that's very discouraging to that point of view. The current feeling among string theorists is that they started off with the hope that string theories would be either unique or almost unique. There might be perhaps a very small number of different theories, but there wouldn't be very many. People now see that because essentially string theories have to be formulated in multi-dimensions, mostly in 11 dimensions, but you have to have a way of reducing the effective physics, of course, to a world of 3 space and 1 time dimension that we appear to live in. And it turns out that there are just many, many, many different ways of making that reduction, and the different ways in which you do it produce very different physical theories. In fact, some people go so far as to speculate that there may be 10 to the 500, pretty big number, 10 to the 500 different kinds of universe that might be reduced from a single string theory. That doesn't sound like a very neat classification, does it? At any rate, my inclination is to feel that there will never be theories that are totally lacking scale parameters of some sort. So I think that the unique answer theory, no fine-tuning at all, the knobs are fixed, so to speak, is pretty implausible. In fact, it's rather fallen out of the argument, the contemporary argument about it. But of course, even if that had been true, it would surely have been astonishing if the only logically consistent theory, in other words, derived from perhaps derived from how to put quantum theory and general relativity together, turned out also to have anthropic fine-tuning. I mean, that's the most remarkable fine-tuned coincidence that you could possibly consider. And finally, just to have another thrust of the dagger in this particular thing, where does quantum theory and general relativity come from? They're certainly not logically necessary theories. A universe with Newtonian billiard balls would be perfectly logically consistent, though it would have a rather boring sort of history to it. So I don't think that's really very much use as a suggestion or a criticism. A much more perplexing point, which I don't think anybody knows really, pro or con, knows what to say about, is the anthropic principle, I say, really should be called the carbon principle, because it's carbon-based life rather than five-fingered Homo sapiens, which lies at it. Maybe it's just that we have very limited forms of imagination. Maybe if we lived in a different universe, we would find that that universe, the physics of that universe, was able to sustain a totally different form of complex structure, evolved complex structure, which would perhaps sustain a totally different form of consciousness or some valuable consequence in that sort of way. Aren't we just too tied to the carbon idea? But it's impossible to know how to answer that. I mean, we really thought about the extraordinary intricacy of the human brain, and surely if that's to be a physical structure in some sense sustaining mental and I would of course wish to say spiritual activities, it seems pretty likely that you have to be able to make structures of that, at least that degree of complexity. And it's hard to think that there are lots and lots of alternative ways of doing that, but it's impossible to say that it's not. So I think that's just a question mark that hangs over it. I don't think it's a point for either the pro or anti-anthropic principle in relation to religion people, but it's just a caution to know. So there we are. It's a very, very interesting revival of natural theology. The old style paleo-natural theology, that as I talked about yesterday, made a mistake. The mistake it made was to set up theology as a rival, I think, to science on science's ground. It concerned itself with the consequences of the process of the world. It concerned itself, indeed puzzling and interesting question of how the complexity of the human eye, for example, could come about through natural processes. It suggested that it couldn't, and therefore you had to have a designer, the sort of designer that ID proponents of today think about, who is a sort of cosmic craftsman, who from time to time, and perhaps very frequently in terms of cosmic history, from time to time, produces new structures just ab initio in that sort of way. The question of how the complex structure of the world came into being is essentially a scientific question. And it was a mistake, I think, for that natural theology to try and answer science's questions for it. If ID theorists could really establish irreducible complexity, which I don't think for a minute they've been able to do, but if they were able to do that, they would have been making a scientific point in the first place. In fact, a point of such scientific importance, I think that it would deserve a Nobel Prize for it. And then you would have an argument about what you make of that. But so the old style natural theology tried to sort of mingle science and theology at the same level, and I think that was a mistake. Its picture of God was God as the divine artificer, the engineer of the world, that sort of thing. But the sort of arguments based on the anthropic principle are a sort of revival of natural theology, but a revival in a different form. And it's different in two ways. First of all, it doesn't seek to rival science on science's own ground. It looks at the laws of nature themselves, which I've already said have to be treated by science as given brute fact. Science does not explain. It says, look, these have a character about them that really can't intellectually, satisfactorily, comfortably be accepted as brute fact. They seem to point beyond themselves in some direction. We think that they point in the direction of a creator God. That's a different kind of argument. It's complementing science rather than conflicting with science. It's an argument which is properly the concern of theology. You know, in Hebrew there are two words that are used for making. One is the ordinary everyday word, asa, which is sometimes used of God, but most frequently just used of people, making a pot and things like that. But there's another Hebrew word, bara, which is only used of God. It represents some particular divine form of making. And endowing the given physical fabric of the world with a finely tuned set of circumstances is something that only God could do. It is pra and not asa. And therefore it is fittingly a subject for theology. The other difference of the new natural theology is that it is more modest in what it claims. It doesn't claim that you're stupid if you don't accept its arguments and believe in God. Its arguments are not logically coercive, but they are insightful. They're saying, look, you can make sense of the world from a theistic point of view in a way that a non-theistic, atheistic view of the world will find more difficult. And incidentally, this idea of a built-in potentiality for fruitfulness as God's important part of God's creative act answers a criticism that David Hume made in the 18th century of the natural theology of his day. He said it was too crude in its picture of God. It's too anthropomorphic. It talked about God making the world in the same way that one might talk about carpenters making a ship. Well, you see, a craftsman producing the eye might be subject to that criticism, but inbuilt fruitfulness is not something any carpenter that's building any ship would be able to do. So the new natural theology is insightful rather than proving. It is complementary to science rather than in conflict to it. And I think it's an important development. And I think it illustrates that it's not a knockdown argument. When we thought about Leslie's parable, we saw that you could either have creation or you could have a multiverse. There were possibilities. I don't think that atheists are stupid, any manner of means, but I do think that theism explains more. And I think in relation to the Anthropic Principle, that is what's on the agenda. Well, as I said yesterday, that's what I think, but now you can tell me what you think. Said to you.
Wonderful exposition of the Anthropic Principle. So who would like to join?
I will quote the story from John Leslie in my next book, and I have improved something. I want to show it to you. I have improved it by a third point. That the third possibility is that someone take in the storage place all the bullet and put false bullet instead of the normal bullet, and that corresponds exactly to the theory of everything. That means if there is a theory of everything, there is one common source for all the coincidence. One common sources for all the coincidence, and I think we can express that even in this situation, there is the need for something else than just pure chance. Because if it's by design that all the people miss you, it's by design. But if there is someone who take the bullet in the storage place and put false bullet to save your life, the other people are not in the plot, but there is still a plot. So it's a way to go in the direction like Stephen Hawking, to say that even if there is a theory of everything, who give the fire to the equations? And so I think it's another way to show that even if there is a theory of everything, it's not a way to cancel the philosophical problem of the Anthropic Principle. But I want to know your opinion on this point.
Well, I didn't think about it a little bit, but it seems to me that I don't see that a theory of if it really is a theory of everything, it should include both live bullets and dud bullets. So it does require the intervention. It seems to, as you phrase the story, as I've immediately taken it in, it seems to require some executive action by a third party which means that the consequences of dud bullets uniformly takes the place of the possible consequences of live bullets. So I think that's I think that's an interesting variation, but essentially on the creation theme. I think I stick with Leslie's feeling that broadly speaking there are those two things, but I need to think about it a bit more.
Yes.
Right. Recently you had a debate with Steven Weinberg about the implications of the Anthropic Principle. Now Weinberg, he looked at the cosmological constant,
Right.
and he did his calculations in relation to the Anthropic Principle. Could you tell us a little bit about what was the thinking of Weinberg himself, being an atheist, when he came to the Anthropic Principle?
Well, Stephen is very robust in what he has to say. I don't remember actually. It's a while ago since we had that debate in Washington. I don't remember what he said about the cosmological constant. To be perfectly honest, he did argue about the energy level of carbon, saying that it was only a sort of 1 in 100 effect or something like that. Well, that may be right. I mean, I don't argue about that, but of course it's very. I mean, it's important to recognise that there are a whole string of these conditions, and not only, and some of them are pretty wide, and some of them are very, very tight indeed. Moreover, it's also interesting that different ones are consistent with each other, that there is a solution which meets them all. I mean, there are different kinds of things. I mean, people argue about molecular properties to some extent, the anomalous properties of water, which are obviously very closely connected with the existence of life. So you have a whole series of considerations of this sort. It's not at all clear, it seems to me a priori, that there would be any consistent solution, even falling within those limits. The fact that they overlap in that sort of way is in itself.
It is quite remarkable, absolutely, yes. On the Weinberg point, he has made some calculations about the kind of value of the cosmological constant that are consistent with the formation of galaxies. And his original calculations on that point put it about a factor of 100 too high. And it's reduced with subsequent calculations that he's done to about a factor of 10. It still looks slightly as though the actual value is a bit small, though it's given the kinds of numbers that are around in cosmology. It might just be that his multiverse explanation might solve the cosmological constant problem, and there's debate about that. Some people say yes, some people like Paul Davis say no, it's not quite right, and so on.
But I mean, also, the 10 to the 120, I think that's based on looking at a natural estimate of the 0 point energy that you associate with a unit of space, isn't it? And that's a scale which is independent of arguments about processes like galaxy formation. I mean, there are lots. I mean, there are pluses and minuses. And certainly, things will change in this area. We don't. A lot of the most acute arguments do relate to bits of physics that aren't very well understood. Galaxy formation is a pretty tricky thing. The very early universe is undoubtedly a very uncertain place to explore scientifically. I mean, I wouldn't die in a ditch for the Anthropic Principle, but I think it's very unlikely that there will not be, if and when the dust settles even more completely as the moment, I think it's very unlikely that there won't be something left to explain of a pretty demanding character. I've tried to be honest in putting it today. I'm not trying to sort of be a polemic theorist.
Yes.
I just really wanted to thank you for a wonderful lecture. I enjoyed it from the first word to the last. And I find quite inspirational too. And I want to thank you too because it explained to me about my late father-in-law. He was a nuclear physicist. And after he retired and he had time to think more about things, he actually turned from an atheist to a believer.
Really?
But not in the kind of evangelical way, but on those lines you were laying out, which I never understood at the time, but I understood it now. So thank you very much.
Well, thank you very much. Yes, I mean, that's another thing to say. Well, even if you accepted the validity and strength of all these these sort of natural theology arguments, it leads you to a picture of God as the creative mind behind the intelligible order of the universe. But it doesn't lead you to God the Father, Lord Jesus Christ. He can only be found in a different form, and more dangerous and demanding form of an encounter.
Yes. Yeah.
There was an interesting report on New Scientist, I think fairly recent, last couple of months, saying that the fine-tuning has only come about because the parameters have only been varied one at a time. And if a whole bunch of parameters were varied simultaneously, other universes in which carbon-based life could form would be possible. Now, the way they've done this was they built a model universe, theoretically, I guess, obviously, and they switched off the weak nuclear force. And they were quite surprised that, yes, they could get carbon, I guess, when doing that. I wondered what you thought of that research.
Well, I think I remember reading the item of the New Scientist, but there wasn't enough detail to really hang on what they were talking about. I can't understand that because if you don't have the weak nuclear forces acting, it seems to me you're going to end up with all helium in the universe. Neutrons are not going to decay. I mean, you really have to look at these things very, very closely. The fact that, I mean, it was a news item, wasn't it? It hasn't recurred again, I think.
I thought it was a full four-page feature, but there was
No.
a little bit.
Well, I'm recording it differently,
Okay.
or maybe I only read the trailer for it or something like that. But well, let's wait and see. If that's the way it falls, then that's the way it falls. But I think not just religiously defensive, but scientifically suspicious about that.
The nuclear physicist defending the nuclear force, I think that's reasonable. You had a question.
I don't want to be too annoying.
No, it won't be as annoying tonight. We'll try to be.
I specialise in it, yeah. When I look at my life, I think, or I invent something, I say, how come I invented this? Now, I look back at my life and I think, now, it could be just chance that all these events happened in my life that brought me to this point. Or it could be there was a plan behind it. I didn't know what the plan was at the time, but it's brought me to this point where I can create that. And that was the idea in the first place. Now my life makes sense. So it seems to me that's the same sort of principle. The human mind has this tendency to, we've got this two ways of looking at things. This happened, and then that happened, and then the other happened. And it was all just, each one was a piece of chance, and it all, well, eventually, those, I did that. But, of course, I could look at it in the other way, the why way, the complementary way, as you put it, and say, well, it was all intended from the beginning, but I can't decide. That's why you've got this 50-50, I suppose.
Well, I
So
think
it doesn't
what
just
you're-
apply to the cosmos.
I think what you're talking about there are, if you like, moves in the game of life. Things that have happened, which may carry significance or may not carry significance. What I've been talking about is not the moves in the game of life, but the rules of the game of life. And back to this distinction between the old style natural theology, which was explaining why things have happened in the world, why the eyes kind of being, things like that, and the new style natural theology was looking to the actual given fabric of the world that creates the possibility of any happening of that kind. That seems to me a different kind of argument. And I don't see that. I mean, I agree with what you say about our lives, and I think actually that's an interesting fact about lives. I mean, quite a well-known Scottish theologian said that the central paradox of human life, or of Christian life actually, was that looking to the future, we feel strongly our freedom of choice and our responsibility for using it accurately. looking back on our lives, we can see also God at work, guiding and leading us. And I think that's true. There is a sort of tension and paradox in that. I think Donald Bailey said essentially that that's the paradox, and you have to live with it. So I understand what you're talking about, but I don't think it's strictly analogous to what I've been trying to talk about this afternoon, which is, I say, the given rules of the game, not the moves of the game. Well, that's what I think.
Thank you. More questions? Yes.
Okay, thank you for that. One question I really had was how the Anthropic Principle, or how Anthropic Principle comes about in terms of God of the gaps. In that, obviously, putting God in the gaps of scientific understanding is obviously not a very good thing to do. But when future understanding fills those gaps in a scientific basis, how does the Anthropic Principle sit outside that?
Well, what's wrong with gaps? What's wrong with gaps is if they are artifacts of current ignorance, in which case they're allowed to be filled. And that's the old God of the gaps, the sort of claim that only God could have produced the human eye by direct action. I mean, that sort of deity tended to be a sort of Cheshire cat, that God, who was always over the next intellectual horizon, always in retreat, so to speak. But there are genuine gaps that exist. And they arise from not the artifacts of human thinking or whatever, but from the nature and defining nature of human thinking. And science is limited. I've banged that drum yesterday. It's very successful precisely because it's limited. It doesn't try to ask and answer every question. It doesn't explain. It uses the laws of nature to explain a great many things that happen, but it doesn't explain where the laws of nature come from. And that's not so much a gap, but a self-imposed, genuine limitation on the form of scientific discourse. And what I'm suggesting is that when we look at the laws of nature and their consequences and understand them a bit better, both in their rational beauty and also in their extraordinary fruitful consequences, they don't seem to be the sort of things that we should simply take as brute fact. They do seem to point beyond themselves. See, you think about metaphysical views in Western thinking. There are basically two forms of metaphysics. There's a materialistic metaphysics or a theistic metaphysics. Each worldview is going to have an unexplained starting point. Nothing comes of nothing. What Hume would say, taking a sort of materialist view, would say, take the forces of nature as your brute fact, and things flow off from that. Take matter as your brute fact. The theistic point of view says, take God as your brute fact, a divine agent, equally brute fact in its way, and so on. And what I've been trying to suggest this afternoon is that, all in all, or certainly so it seems to me, that the second strategy, the theistic strategy, is the more promising and more comprehensive source of understanding than a human brute fact of matter approach. I mean, our whole picture of nature of matter, of course, is vastly different than was accessible to somebody like Hume in the 18th century. Sorry, carry on. Yeah.
I agree with you. I was just wondering whether you thought at any point in the future science could provide an explanation other than vague attempts at multiverses that would explain the anthropic nature of the universe.
Well, I just can't see that. I mean, if you were to ask someone like Peter Atkins at Oxford, he will say, yeah, for sure, science is all-powerful, it would explain everything. But that's just an assertion, and it's a polemical assertion, and it's an extremely implausible assertion, in my view. And made with passion and with rhetoric, I just think it's wrong.
Yes.
I've been passing the rest of my
More
own
serious question. As one who was interested and slightly disturbed by Hoyle's continuous creation 40 years ago, I suppose it would be, did he make that gap to talk about the intelligence still holding to continuous creation, or had he changed his mind?
Well, actually, I'm sure you know that Hoyle and Bonnier were partly drawn to the scientific theory of continuous creation for meta-scientific reasons. They thought that Big Bang cosmology, of course, Hoyle invented the phrase Big Bang and intended it as a sort of joke rejection of the idea. They thought it did threaten the theism, and they wanted to get rid of that. They were all convinced atheists. Well, Fred was an extraordinary character. I must get on to stop talking about him, but Fred was first of all extraordinarily stubborn. He never gave up, really gave up any idea. So, I mean, he continued to hold on to continuous creation long. I mean, essentially what was the coup de grace of continuous creation was the discovery, first of all, of the background radiation, so naturally explained on a Big Bang cosmology, so requiring such extraordinary ingenious contrivance to then of course also the hydrogen-helium ratio, things of that nature. But Fred was I say, would never give up. And I don't know. I lost touch with Fred when he retired to Cumbria, but I doubt whether he ever completely gave up the idea of continuous creation. The other thing about Fred is, there are some people who are just fantastically fertile in producing ideas. I did my PhD under Abdus Salam, and he was another person of this kind. And people who are like that have lots of ideas, and some of them are good, and inevitably some of them are not so good. Some of them, in fact, are frankly bad. And if you're a very creative person like that, you usually can't quite tell which is which. In fact, I'll tell you this. Salam once said, when I was a research student, Salam once said to me, publish all your ideas, he said. They'll remember the good ones and forget the bad. And even as a young man, I could see that wasn't the best sort of advice to follow. And Fred was very much like that. I mean, his work on nucleogenesis was wonderful, I think, certainly a Nobel character. The steady state stuff was important. It didn't turn out to be the right theory, but I mean, it was a well worked out scientific theory in its initial stages. All this stuff about cometary diseases and things like that were frankly, and about the faking of Archaeopteryx and so on. I mean, they were bad mistakes. And I suspect that's why, I don't know this, but I suspect that's why the Swedish Academy didn't give him the share in the Nobel Prize for nucleogenesis that he should have received. I mean, he and Willie Fowler worked together all the time. You used to see them when they were working here in Cambridge, they were together all the time, and Fred used to go to Caltech all the time. Willie got a share in the Nobel Prize, Fred didn't. It was a disgrace.
Mm-hmm. I think the curious thing is that, if I'm not mistaken, that Fred Hoyle also had was involved in these calculations about formation of helium and the light elements in the early universe, which, in the Big Bang, which would be peculiar given given his rejection of the Big Bang.
I didn't know that, Ronnie, actually, but I was
I have a feeling that's right. I can't exactly remember.
You told us that Fred Hoyle was a committed atheist.
Yes.
And so why was the reason he was so opposed to Darwinism if he was an atheist? Because there's a famous story from Fred Hoyle saying that you cannot have a jumbo jet by a tornado.
No, he was certainly, you're absolutely right. Well, I don't know. I mean, I don't think, what I just said, in more diplomatic language, I'll say that I don't think Fred had a wholly consistently reconciled worldview. I don't why he took against Darwinian evolution. I don't know the answer to that. But again, having taken against it, he wasn't going to be very easily persuaded, I think. Do you know anything about that? It's a very interesting question.
It's an interesting question.
Yes.
But was it against Darwinian evolution as lock, stock and barrel, or was it simply against the origin of life? Or, what are you saying?
Oh, well, probably, that's probably quite fair. But I mean, all the that's what motivated the Archaeopteryx.
He was also keen on panspermia.
Yes.
Of course, yes. Yes, that's right. Yes, you
Like Francis Crick,
Yes.
Yeah, I know. Yes. Yes. Anyway, let's leave the byways of scientific idiosyncrasy for a while.
Yes, we've got a little bit more time for questions. Anyone else want to?
Sorry, I never succeeded talking for an hour. I usually say what I want to say in about 50 minutes or so.
I know about it.
You could broaden it because we didn't answer all the questions last night in the box. There may be some
There
people
were
whose
one or
questions.
two on this topic, which I
Well, I
left
just wondered if
because
we neglected some of these questions which were in the box.
I left one. I think I left one or two because for that reason.
You could give them all to John, just all the ones that are left.
John, just while Rodney is...
Of course, yes.
You could envisage somebody saying that the talk of a fruitful universe looks very plausible as long as we're talking about planet Earth. But we have so little knowledge about whether there is any carbon-based life on any other planet, anywhere else in the universe.
Right.
And yet we have this vast universe. Might that not actually accentuate the force of the skeptical argument that this is just a lucky fluke that we happen to be here? And I'd just be interested to know how
Well,
you
I
deal
tried
with
to
that.
deal with that when I was saying that the universe has to be as big as it is if it's to have lasted the 14 billion years that have produced us. Now, whether you think that's a sufficient grounds for having a big universe is up to you to decide. But it does at least mean that it does at least mean this, that if there's no other argument, and there might be many other arguments, there's no other argument, those 10 to the 22 stars minus 1 for our sun are not redundant in the sense that we could have done without them. Well, so I don't feel myself uneasy by that argument. I mean, the question of whether there's life elsewhere in the universe is an interesting question. Of course, the answer is we just haven't the slightest idea. We haven't the slightest idea because we don't know how difficult it is for life to get started. I mean, you may need very, very specific sites for life. I mean, not just the right temperature and chemicals and stuff, but maybe a big satellite like the moon to stabilize rotation, produce big tides that scour the Earth for mineral resources and all that sort of thing. There may be very, very tight specifications for sites capable of producing life, but there are 10 to 22 stars, most of which probably have planets. You surely will have a few possibilities to be found somewhere else. What we don't know is how, given all that, given everything's perfectly set, will it happen? We don't know whether it will happen because we don't know how it happened here on Earth. And Francis Crick found it so difficult to think, and certainly not influenced by any religious agenda of his thinking, that to see how it happened once, he had to go to panspermia or that type of thing. And that's why, of course, if we were to discover life on Mars and it were to have a different genetic code, so it was unambiguously an independent generation of life, that would be a tremendously exciting discovery. But if it's the same as us, then we don't know quite what to make of it, because it might be some exchange one way or the other. But it's a very important issue. Theologically, of course, it's been debated for a long time. Well, as soon as Galileo made it clear that the planets were made of the same sort of stuff as the Earth and not the quintessence or something like that, people began to speculate about Venusians and Martians, then to ask the question, did Christ die for the Venusians, and so on. And basically there were two lines of thought. One said, to redeem creation, it is sufficient for the Word of God to become a creature somewhere to redeem the whole of creation. And there is a certain theological logic in that. On the other hand, it seems a bit hard on the other people not to know what's happened. So the alternative thing was to say that if there are little green men who are in need of redemption, then the Word will take little green flesh, as the Word took our flesh, for their redemption. And there is no inconsistency in multiple incarnations of that sort, in different forms of intelligent beings. I think most Christian thinkers would think that God becoming human twice was an unacceptable possibility. But again, I mean, it's, I belong to the second party. I mean, I belong to the Little Green Men party, but I mean, for what it's worth. Right, you got a conundrum?
Well, I mean, I think you've got, what's the one? Yes, about the fine-tuned business. I mean, what one person raises, I think it's very similar to your point, actually. Is it another example of complexity demonstrating intelligent design of the universe, or is there another philosophical and theological framework in which fine-tuning can be considered?
Well, that's back to this distinction between Marat and Assar. I mean, the ID, the contemporary ID movement, is speaking about God making things in that sense, and what the Anthropic Principle argues are talking about God endowing creation with potentiality to make itself.
Yeah. Exactly. Thank you.
Let's make a difference.
Yes.
Can I just ask a question on string theory? So there's been a couple of books out recently, one by Lee Simone, and I don't remember the other one, very critical of
Not
string
even
theory.
wrong if I chapter's name I can't remember.
Okay.
That's right.
Okay, yeah, so, and they, I think both roughly say the same thing, that, you know, string theory's got too far, it's gone too speculative, and it's not testable, and we ought to return, you know, we ought to bring back the balance a bit and have more experimental physics and stuff we can actually do experiments on.
Yeah.
And even I think there was a critical review in Nature saying, well, if we allow too much of the speculation of science, well, why not have intelligent design, as we were talking about yesterday in science, because that's equally speculative and there aren't any, you know, if we criticise ID for being untestable, well, you know, isn't string theory in the same category, I think. So what do you think in principle there are any experiments to test string theory, or is there no way people actually think of at the moment that would actually be
Well, I mean, nothing sort of cast iron proposed. Let me say a few things about that. I mean, first of all, string theory is, at one level, string theory is the exploration of the riches of relativistic quantum theory. We know that when you put relativity theory and quantum theory together, you get a richer theory than is simply the sum of the parts. So there are properties of relativistic quantum theory that are not properties of relativity on its own or of quantum theory on its own. And string theory at one level is the exploration of relativistic quantum theory formulated not in terms of point entities, which is a conventional way of formulating it, but in terms of one-dimensional or higher-dimensional entities of strings and brains and things that people talk about. In one sense, it's worthwhile to explore the richness of relativistic quantum theory. It's quite another thing to claim that in doing that, you are finding a theory of everything or the next big step in physics. You are talking about processes whose natural scale is at least 16 orders of magnitude smaller than anything to which we have direct experimental access. And the lessons of history are not encouraging to the idea that we can second-guess nature 16 orders of magnitude beyond what we actually know. There are attempts to try and find more nearly observable properties. I mean, for example, one of the developments of this thing is these so-called brain theories. These are multi-dimensional entities within the 11-dimensional space, which can encapsulate universes and things like that. And the theory is that if they are independently, if you have these brains, the universe is located on them, then they are essentially independent of each other. But when they come very close together, then there can be some sort of tunneling between one and the other, and you might see enhanced effects, which sometimes are claimed might be at an experimentally observable level. I think nothing for sure has emerged out of that, but that's the only hope of making some sort of empirical judgment about these things. I mean, it's inconceivable. You just couldn't have an experimental setup of a feasible or envisageable type at the moment that could get down to the small businesses involved. And I think even with possible developments in accelerated design wouldn't be possible. See, my old subject of particle physics faces a very difficult situation. During the whole time I was with it, it was largely experimentally led. Theorists, there was a very clever theorists around, of course, but we have a theoretical community that's sort of limping along behind the experimentalists most of the time. The experimental input into high-energy physics is drying up. The last big machine that's been authorized is the LHC, the Large Hadron Collider, due to come on stream at CERN actually sometime this year. It's possible that there might be one more machine beyond that if they can cobble the money together. But these things are extremely expensive, billions of dollars, and taxpayers are reluctant to spend money. So there's a real chance that the high-energy physics, which is sometimes called particle physics, is just going to run out of steam. And but I do think it's an unhealthy situation in which so much speculative work dominates theoretical thinking. And not only dominates theoretical thinking, but in this not even wrong book, I haven't read Simone's book yet, let's get hold of that and read it, but in the not even wrong book, it's pointed out that controlling positions in prestige academic institutions in theoretical physics are dominated by string theorists and likes like. And So I think there are genuine grounds for being anxious about the academic situation in that respect.
Thank you, John. Yeah.
Different subject. I was thinking about what you were saying about Fred Hoyle. When he got an idea, there was no dissuading him. And one of the things that is often quoted as being a barrier between science and theology is experiment versus faith. But in actual fact, Fred was showing there faith in himself, faith in his ideas. And isn't faith what actually motivates us to reach out and look for answers, reach out and do things, as much in science as in a religious belief?
Well, I think you make a good point there. Yes, I mean, I do think that the search for truth requires commitment to the truth as you see it. It doesn't totally blind or unyielding commitment, and commitment more in that end of things than perhaps was really good for things. But you did it. I mean, I talked about Polanyi yesterday very briefly. Polanyi's book very much emphasises the role of commitment. I quoted his remark from the preface: "I'm writing this book to show how I may commit myself to what I know believe to be true, knowing that it might be false." I don't think Fred ever knew that it might be false. That was the bit that was missing his point of view. I mean, people like Fred are sort of iconic figures in me. There's lots of stories circulating about them. Stories are quite often critical because they're drawing attention to. I mean, big people have big gifts and big faults. And you can't have one without the other. But generally speaking, the anecdote in itself is affectionate and respectful, though not adulatory.
Well, we're approaching tea time. Maybe we'll have a last one.
Okay, mine's actually a question I put in last night and didn't get asked. So
Oh,
I'll ask it now. As this is time, I'm going to hijack it. I'm not a physicist, but obviously from the history of science we see these huge shifts in our understanding from, right from sort of Ptolemy to Copernicus, going through sort of quantum theory and from Newton and all the rest of it. And science changes in these huge fundamental ways in which we understand reality. So my question is really, how do we convey to Christian theologians to engage with that when one of the big principles of theology for a lot of people is that it's an unchanging fixed truth? And I come across that quite a lot as a sort of a barrier to engagement where people they say, what's the point? Science just changes all the time. And how would you address that question? Because I think that's quite a key one.
Well, first of all, I don't think that theology is so unchanging as that. I think you have changed, but also with continuity. I tried to speak of myself yesterday, being someone who wants to be a part of an unfolding Nicene tradition, if you like to put it, those in Christianity. But it doesn't mean to say that people who think, take this question of God's relationship to time. Many of us think about it differently than certainly than Aquinas would have thought about. So there is change in theology. Also, I think of course you have to be careful about science, and pictures do change. I think it's very, if I may say something about the history of science, I think it's important to think about the history of science, particularly to concentrate a lot more, perhaps than is conventionally done in some quarters, on the nearer history of science. I mean, Ptolemy and Copernicus and that sort of thing. It's very instructive, but that's the beginnings of a change. If you look at modern science from, say, towards the end of the 18th century onwards, of course you've got phlogiston and caloric and things like that, but by and large there is a degree of continuity. I mean, quantum physics is certainly very different from classical physics, but we have correspondence principles. We have to recover the successes of classical physics in the appropriate domain, as well as, of course, adding to that the new insights of quantum theory in other domains. I mean, a sort of Kuhnian picture of paradigm change in which Newtonians can't talk to the quantum theorists. They just don't have a language in common, it's incommensurable. And that's a gross exaggeration. Einstein's general relativity didn't show that Newton was wrong or useless, showed that Newton was limited and exhibited the limits and improved upon it and those sort of things. So I think there are clearly bits of scientific understanding of the world that aren't going to change, particularly structural bits. I mean, atoms are here to stay. That's for sure. There's some sort of discrete I mean, our views of what atoms are have certainly changed in the course of the 20th century, but in a way that I don't think is radically revisionary, though it's certainly more profound. So I don't know what you think about this, John, but
as you were speaking, John, I thought of one other thing, which is that it is true in the earlier periods you can show, for example, the role of religious belief in shaping people's attitude towards scientific theories in ways that are not so obviously discernible in the modern period. So there's a very significant change in that respect.
Yes,
I think the earlier period would also illustrate your point, though, that there are things in science which are established and which remain as part of the body of knowledge that have so far resisted the falsification process. Nobody is going to deny William Harvey's what was once a theory, that it's the blood that pumps the heart. We're not going to go back to a Ptolemaic system of the universe. So I mean, the earlier history would still substantiate your point, I think. But I would also agree with you that modern scientific culture does show contrasts with earlier scientific culture. And it's reflected in the fact that Newton would have said he was doing natural philosophy, and you were a professor of physics. And, that there is a difference.
Also, I mean, an element of it, I'm not going to stress this, an element of it is I think there always have been meta-scientific notions and motivations present in scientific thinking. But the way they're phrased today is more discreet and more hidden and more, in some ways, more dangerous. I mean, back to our old bait noir, Richard Dawkins. I mean, Dawkins' scientistic invocation of evolution as the explanatory principle of everything is certainly not evolutionary biology in a genuine sense, but it's acceptable in a way that appeal to the wisdom of God manifested in the works of creation would not be acceptable from our side today. So there are shifts in forms of expression of what's acceptable. But I think that there will always be, simply because science doesn't answer even these elementary question of causality and temporality wholly on its own ground.
I mean, is the theological analogue there really with that? I mean, I can't ever see us quite reciting a new Nicene Creed. And that would be horrifying, right? But I guess we go on exploring that and engaging with with modern philosophy and so on. I mean, what would you say about the theological?
Well, yes. I mean, somebody said yesterday. If you make an analogy between science and theology, the science to look at are not the experimental sciences, but the historico-observational sciences like evolutionary biology and physical cosmology. And where there is a sort of foundational story which is going to control, within certain limits, the subsequent development of thinking. Obviously, you get big developments of thinking. Neo-Darwinism comes along, genetics explains what Darwin couldn't explain, and so on, but you don't lose that. The role of the Nicene Creed is, I think, to give a very skeletal affirmation of what I thought what the Christian Church judges to be its foundational events and insights.
Well, maybe we should have tea. Very good.